First of all, we talk like this at the first Wednesday of every month. We're talking about building forensics, what most people use their diagnostic equipment for, and all of the different equipment you can get at TrueTech Tools. You should go check out their site. It's so deep that you could start scratching the surface and really get more than enough to work with. Once you have diagnostic equipment and you're using it for things like energy efficiency or energy audits or home performance testing, then you can very easily start transitioning to what I do almost exclusively now, which is find the sources of problems in people's homes and buildings. The testing is the only really tried and true way to do that. A lot of people think that inspectors do a good job of that kind of thing, but inspectors aren't looking at a dynamic state of the building. And also, most energy audits are very standardized. They're going by a script that someone else in an office somewhere has written. I'm not going to name the standards that I'm talking about, but in general, you want to start to customize this stuff because you can find out anything in any building. And drywall can't hide it, complicated systems can't hide it. So, first Wednesday, come back for more. It's always a new thing. I'm basically talking about jobs that I've got. So, today, if you decide, wow, I really like this, I need more stuff, there is lots more videos. There is my radio show, which is called the Building Performance Podcast, which Bill Spohn, who is also on this webinar, has been on. There is my book, which is called Home Performance Diagnostics, which you can get online. There is the software tool that I use myself called App Reports, and I build for other people as well. I have the certification exam prep stuff, and then also I do video consulting for people. If you've got a job that's really giving you a pain in the butt, or if you need some help with coaching on the way that you're running your business, your diagnostics, I can do that now. And in the fall, we have the Fall Fast Track. So that's my 6-week mastermind course, and that's for the cream of the crop. So if you have been through the certifications, you've got your equipment, and you want to take it to the next level, that's how you do that. I want to just point this out real quick. This is a video that we released last week. It got picked up by several different websites, including the Journal of Light Construction. And I intended... and my state association, the IAER, the Illinois Association of Energy Raters, has intended for you to take this video and start teaching your clients how this stuff works, because people don't know how nightmarish building a house is. For example, this is a very nice Energy Star certified kitchen exhaust hood. Any person looking at this would say, yep, that looks right. It's clean, it's white, it's got the duct come out of the top that's obviously going to outside, obviously. However, this thing is going to be tested, and it's going to need to be tested because it is going to malfunction. Even though it looks really nice, there's a lot more underneath the surface. So here's what we're going to look at. The testing is going to show in another year or two, when we come back to this thing, that the static pressure is high in the duct that's going to outside. Just like blood pressure, when the blood pressure goes up, your blood flow goes down. So the airflow is going to be lower than designed. If this is a 400 CFM exhaust fan, or 200 or whatever it's designed to, by the way, if you're listening to this and you're about to install a 1200 CFM kitchen exhaust fan, please stop and talk to someone before you move on. My phone number is readily available online. So anyway, if it's 200 CFM, it's going to be less than that. And the air quality inside your space is going to be not good. It's going to have increased humidity. It's going to have carbon monoxide hanging out. And it's going to have odors, the cooking odors that you're trying to get rid of. And if you're smart and you use this thing every single time you cook, because of course every single time you cook with gas range, you are creating carbon monoxide, none of that stuff is getting to the outside. Here is an example of why that happens. This is how it gets ducted to the outside. Now, this is a job that I was on, that the picture that you saw of me all muffled up with my ski mask on is inside this building. This is a multifamily project. My clients are excellent. Everyone involved in all of my projects are excellent. I do not work with jerks. However, this is a problem that is an oops problem. So this duct is coming through this panelized concrete wall that you can see there. We see the ceiling trusses that are holding up the next floor up. This is what it looks like from the outside. The one on the right is the boot, which is the box that duct plugs into. It takes up the entire port that's built into that panelized wall structure. The one on the left, the little white stripes that you can see going up and down there, that is the roof truss. So the truss that's holding up the flooring system is actually blocking half of this thing. And what that means is that this happens when you connect it. So this duct doesn't actually take a straight shot to outside and then empty out into glorious outdoor air. It actually has to take a 90-degree turn and then another 90-degree turn at the very end of its run, which means that it's not going to function the way that you designed. So again, this is what is going to happen with that. Now that's the simplest example of what this means. You really need to start knowing what to look for. So I'm going to give you an example that you guys may have seen. If you work in existing homes, and I know from seeing the attendee list on this webinar that many of you, number one, are buddies of mine, which hello to everyone who is a friend of mine on this webinar, but also that you guys know what you're doing. You've been in existing homes. So let's look at this. This is a side attic. The side attic problem is pernicious. Most people think that by looking at a side attic they can tell what it's supposed to be doing. Absolutely not true. Here is a perfect example. So the testing in this case that I'm going to show you is going to be that the blower door test has a higher number than you want. Of course, we measure air leakage into and out of homes in CFM50. That's the blower door test that you compare everything to. So the CFM50 is going to be higher than we want it to. And by the way, the word designed is not an assumption. If you are designing a home to have a certain air leakage rate, good for you. Most people are not. And if you are about to buy a home and you're listening to this and you're a home buyer or a homeowner, you should know that that is not an assumption that you should make, that people are just designing tightness levels. However, let's assume that you are. So the zonal pressure testing, or ZPD, is going to show that there is air leakage to both inside and to outside in this little space, this side attic that we've got. And by the way, a lot of people have side attics and they don't know that they have side attics because they don't think about the geometry of the inside of their house compared to the geometry of the outside of their house. So you should think about this on the top floor of your house. The advanced leakage quantification, which is this way of knowing exactly how much the CFM50 could be brought down by effectively air sealing a certain zone, is going to show that there is a significant possible reduction. And the infrared, which I always use because it's sexy. It's a way to show with one picture what 1,000 words could do, right? The air leakage into the building cavities, including floor cavities between conditioned spaces, interior wall cavities, stuff like that, that people would never imagine that air from outside is getting into, or that air that is inside that wall cavity is getting out, is going to show up. And all this stuff is going to be totally obvious when you see this. This is a picture that is worth 1,000 words. Obviously, something is wrong with this door. Now, this is what this door looks like. Nice, ordinary interior door. I'm on the top floor of a little bungalow here in Chicago. You open up the door, and this is what you see. Uh-oh. And you step all the way inside, and oh no, this is terrible. So first of all, interior door. Secondly, using it to keep things that are probably not supposed to be kept in freezing temperatures. We've got all kinds of different furniture and some laundry and things like that. Now, this is what's important. On the left, you have the R11 bat that is installed in the roof. That says that this side attic is supposed to be insulated away from outside, meaning it's not part of outside. But this insulation on the right, that's, by the way, affixed in place with a plastic vapor barrier, which is not a good idea. And by the way, the fact that it's all dirty shows that it has been filtering air. That's pretty gross. So both of these means that this side attic is not supposed to be part of anything. It needs to be either 100% inside the envelope or 100% outside. So right now, it's trying to be neither. And that is bad news, because what that means is that we have no idea what temperature or relative humidity it is going to be in this space. And that's when you get mold, moisture, durability, rot, all that stuff that's terrible for most people. So the reason that they put the insulation in both places is because they did not understand what was going on. This is an oops moment. These people are probably smart people. They probably built homes before. The reason that they decided to install so much insulation is because of this plumbing. They want to protect the plumbing. Don't let the pipes freeze. And I've got other videos on why pipes freeze and things like that, but ultimately, this is totally misguided. This is not the way to fix this. And by the way, this is how you can tell. See the staining on the wood? So the staining shows that there has been moisture hanging out on this wood. That means that the temperatures in here have not equalized, because of course inside your house, stuff isn't wet all over the place. In this side attic, the fact that stuff is wet means that there's something going on in here that we need to know about. So first of all, you pull up the wood and you take a look down here and you find everything that is important about any home's performance. Most normal people, most consumers and homeowners and home buyers, and if you're watching this, thank you for being here, think that most of the important stuff is the doors and the windows of their house. They always call me saying, hey, can you show me where all the leaks in my doors and windows are? Yes is my answer. I can show you that stuff, but that's the lame stuff. That stuff does not matter. What the stuff that's really, really important is underneath the skin of everything, and you cannot hide anything in any building ever, because the technology that people like Bill Spohn, who's on this webinar, have helped to develop has advanced so far that the technology beats everything. So you can test everything, and I recommend that you do. Here is our plastic-coated interior wall. This is also called a knee wall. A knee wall is a wall that separates an attic space or a buffer space from conditioned space. This is above, and this is exactly the same depth below. So I just basically dipped my camera below, and you can see that where you can see that the wall there is about 2 feet away from me, I can reach all the way into the house here. This is the problem, and this is the kind of thing that people just don't know exists. So you need to show them pictures of this stuff because they don't get it. They don't even know that there is a cavity in there necessarily. So again, what the testing is going to show on this side attic is that the blower door is high. Zonal pressure shows that it's kind of confused. It's part inside, part outside. By the way, the reason zonal pressure testing is so important is because in order to figure out which way you want to push this zone, clearly it wants to be either totally inside or totally outside. I just find out where it is on the spectrum right now. And by the way, this place is only 25% outside, which means it's 75% inside, which means it's a lot easier to just bring it 25% inside than to push it 75% to the outside. So that makes up our mind very, very quickly. So let's look at the last thing, and we're going to keep this quick. This is a very nice house, over $1 million, perhaps over $1.5 million in a very nice neighborhood, very expensive. The builders who are my clients are very nice people, and they are excellent. They pursue excellence. However, most people have no idea that a building project is not the source of one person's work, right? We all know that lots of people are working here. You can see a couple guys on the left here working on this house. Essentially, we don't have right hand and left hand. We've got like 1 million right and left hands, and none of them knows what the other is doing. The architect on this doesn't know what the framer's techniques that they're going to be using are. So all of the wood in the house doesn't necessarily reflect any of the specs that the architect put in there because all of it is kind of figured out on site. So, by the way, when you see a roof that's this complicated, that is the kind of client that you want to chase after. After somebody has moved in here for a year, they're going to want you. So here's what we're going to see with this house, unless they do the fixes that are very easy to do in rough-in when the place is being constructed and very difficult to take care of later. And first thing you always need later is the building forensics. So when you run the forensic, first of all, you'd find that the blower door, if you have designed it, which in 11 states in the country, which have the 2012 IECC at this point, means that they have to design a pretty tight enclosure, and for the other 29 in addition to those, and for all of the rest of them by 2017, everyone is going to have to design their enclosures to meet a blower door specification. This is not something that's optional. Everyone is on the train at this point. So you will find out that it's higher CFM 50 than you'd want. Zonal pressure is going to show that there's air leakage all over the place. If you use pressure panning, and pressure panning is simply zonal pressure testing for a zone that doesn't have a door on it, you would find out that the walls are actually really well connected to outside. And with infrared, everybody's favorite, but not the most important, you would find that air leakage and insulation dust continuity all over the place, even though this place is going to be spray foamed. And that is what I want to make sure that people understand. Products will not save you. And anyone who says that this is our product and it is going to save your day, automatically be suspicious. No product does that. Here's why. Number one, this is a great product, right? Home wrap. Everybody likes it. If it's taped, first of all, it's not. Second of all, see the little nicks on the left? That stuff, incredibly important, right? And if it's the only layer of air sealing in the entire house, then it is the only important thing. So if this is one of 5 or 6 different air sealing layers, then great, it can be nicked up, that's okay. But most people are not designing their enclosures to be really, really well air sealed. This is inside the front porch roof. And of course, the way that the sequencing ran on this means that the house wrap came along after they had already framed this thing up. So it's just flapping around in the breeze, and what you can see right here is joists. These are the ends of floor joists that are coming through here, and that means that there's major air penetrations through there. This is the kind of thing that I could find later with pressure panning on this floor, front porch cavity roof cavity and find out that we need to break into the roof cavity and air seal this thing. And honestly, it's a totally duh moment. Everybody on this job, really nice. Everybody's trying to do a good job, but frankly, it's hard. You got to check yourself. And this is the thing that's not happening. We are not checking ourselves. It's not part of the culture. This is a cavity that's on a what's called a cantilevered floor or a bump out, and they have stuffed in temporarily these bats of very nice non-splintery recycled denim. But if that doesn't get taken out and replaced with something that's rigid, there will be comfort problems in the bathroom above this, period. And I see that all the time. Almost all my jobs that I'm getting hired on have something that's like this. It's just like, oops. So when we get to the basement, we find out that the framing is so incredibly complicated. And if you are an insulator or an air sealer, then you know looking at this picture that you're going to increase your price. If you don't know, and by the way, I remember not knowing. I used to be a piano player for ballerinas all day long. I made up music for a living. So when I step into a house now, there are still things that I'm fuzzy on exactly what they mean. When you have seen enough new construction and you start to realize, like, well, how exactly are you going to fix this thing? That's when you really get your legs under you. So just make sure that if you're not out there looking at this stuff, get out there. If there's a house being built in your neighborhood, even if you're a homeowner or a homebuyer, go take a look at it and see if it makes sense to you, how you would actually fix the enclosure to make it perfectly done. The HVAC person on this job, fantastic. The framer on this job, fantastic. Everybody involved, fantastic. But they are not talking to each other. That is a duct that is located pressing up against the rim joist, which is the very edge of the house on top of the foundation wall. How in the world are they going to air seal and insulate behind that duct? The answer is they're not. And the secret is that no one's going to say anything until the homeowner moves in and finds out that that duct doesn't blow warm air, because it's losing all of its heat straight through this uninsulated bit at the outside. That's totally, totally avoidable. And you can see here that this is the rim joist, and this is a little detail that was very mystifying to me. They have essentially an eye joist next to the band joist or the rim joist, which is made out of OSB. That's oriented strand board. It's like plywood, basically. So what that means is, unless they're doing spray foam in the rim joist here, there's no way that they could possibly air seal that, because it's going to look something like this. That's really a crazy shape to try to get some blocking in there and try and seal everything up. It's just too complicated. So this is the kind of thing that getting the architects on your side, getting the framers into a conversation, getting the insulator and the air sealer all at the same table at the same time, and especially with the plumbing, as you can see the copper pipes there, and the HVAC guy, and everybody basically needs to be involved in these talks, because otherwise somebody like me gets called a year into the living situation before the builder warranty runs out. And I get hired to tell people what they should go after the builder on. I work in two scenarios. In the new construction, I work for builders to prove they did it right. And I also get hired by the people who want to go after the builders. It's a sad state. This is the kind of detail that's really easy to let slip by you. How in the world are you going to get insulation or air sealing up into that little gap there at the corner, right? And you can start to see this is all kind of honest stuff. And when you look around any new construction project, you'll see this exact same stuff again and again. Again, very complicated. How exactly are you going to do that? That's the right question to ask always. How exactly are you going to do this? Because everybody says, oh, we're going to build this green, or oh, we're going to build this high quality, or you're going to get, this is a luxury home, or we're going to do this really energy efficient. What exactly do you mean by that? And that is the core of why testing is important, because the testing shows what exactly I mean by that. I mean it's going to be less than 1.5 air changes per hour at 50 pascals, and I mean that every room in the house is going to zone at less than a 5% connection outside. For example, if I have metrics like that and no one else in the world, and by the way, no one else in the world does have metrics like that, because people's marketing departments are very, very slow and they don't get the science. Once somebody starts trumpeting this stuff and showing people what it actually means, and that's why we make the videos that we do and hold the webinars and make the radio show, then everything changes and no one competes on price anymore for those clients who are willing to pay for having it done right. This is over a window on an exterior wall. This place is going to be cold. It is solid wood for 6 inches. Walls that are 6 inches deep are supposed to be R20 of insulation. This is going to be about R6 of insulation. That's less than a third, and it's going to hurt the overall comfort of this room, because the way that insulation works is not linear. It's actually exponential or logarithmic. Obviously, we're going to have a very nice time plugging in our radio outside in the backyard, but this air is going to come straight into that wall, and it's going to get into everything and come out in the light switches, and people are going to go out and buy those foam gaskets, which don't work at all because that is a point fix. It's not fixing the fact that air is getting into the wall in the first place. When we go up to the top floor, you can see that this thing is called, it would be called a top plate, except that it's really just for fire blocking, except for the fact that it's really not going to do anything because it's in the wrong place. So we need to be able to seal up this wall to make sure it's not going to leak air up and into the attic cavity. And you can see the same thing here. We have kind of a difficult time figuring out exactly how we're going to air seal this. And when you start thinking about how the drywall is going to get installed, that's when you start to realize, this is where I need a new kind of product or approach. And there's all kinds of different things being developed for this. But by the way, also, you're going to have to get the insulation over that little barrier dam there, which is the this wood member right here. They're going to have to blow insulation up and over this thing to be able to get this top plate insulated. And they may or may not be paying attention to that day. So you need to make a note about it before, you need to inspect for it after. This is the kind of thing that's really just cracks me up. Because when we start doing fancy stuff with houses, it's kind of like it builds on itself. It's this gingerbread house effect, and we just get more and more little crenellations and ornamentation. It's all very beautiful, but the more beautiful a house is, the more problems it has. And I can attest to that because all of my clients generally have very nice houses, and my best clients, the one that pay me the most, have $1 million or more houses, right? And they're very well to do, and they're very easy to make angry. So if you want somebody who's going to definitely give you a hard time, go find the millionaires. This is the mechanical room in the very top of the house, and this is a new thing that people are trying to do where they enclose the mechanical system, the furnace, the air conditioner, in the attic inside of its own insulated and air-sealed room. However, in this case, as in so many cases, we have a wall right here with no top plate. That means that this wall will have air leakage. And what we need to do is make sure that the wall, the air inside this wall isn't able to radiate out because air travels through insulation. So no matter how much insulation we put in here, it's going to be a problem because it's going to be picking up and moving it up through. And the last thing is here, you can see that this does have a top plate, and I'm sorry about the fuzziness, but the top plate is not going to be in full contact because it's the same size as the studs that it is topping. You need to use a bigger, remember, a 2x6 for 2x4s because you're cutting it on this bevel right here, as you can see. So all of this stuff is going to point to testing later. And the testing, and again, I see this where the houses that I'm testing are both new and old. Most people think that new homes are better. Absolutely not true. New homes have these kinds of problems, which are totally avoidable, which is even more sad than old. So what I wish is that I was fighting against some evil supervillain who is going around messing up all of these houses' performance and making people uncomfortable and making people's kids have asthma and all this horrible stuff. And instead, what we are using is building forensics, which is incredibly sophisticated and so cool. And people are willing to pay for it because it proves what is going on inside houses. What you are fighting against is not a supervillain. It's dumb. It's always like, oops, my bad. I forgot to pull the tape off of something. And honestly, every single problem that I find always comes down to this. Oops, I guess that got away from me. And the way that we fix this is just by inspecting and testing. So make sure that you don't end up being one of those people that's, somebody says, very nice guy, like him a lot. I'm sorry, just didn't do a good job. Make sure that you're always inspecting and testing. And if you are not in charge of your project, make sure that somebody is hired who is in charge of that because it does not happen in real life unless you explicitly ask for it. So thanks very much for your attention. I will take questions at this point for a few minutes. And Bill, if you have anything to add, I'd love to hear from you as well.